Welcome back, everyone. Today we're going to have a workshop on rational functions. There are three objectives for this, and for objective number one, I can determine the asymptotic restrictions on the domain of a rational function and represent domain and range using interval notation, inequalities, and set notation. Let's begin. Example number one. What are the domain restrictions for the function y equals x plus 5 all over x minus 3? Okay, we don't need Desmos for this one. We just have to understand that in a fraction, zero denominator is not permitted. So your restriction here is that if x becomes a 3, then that denominator will become a 0. So that is your restriction, that your x must not be equal to 3. So in this case, a equal to 3, a, which is x equal to 3, is your restriction. Example number 2, what are the domain restrictions for this one? And now for this, let's go ahead and plug this in on Desmos. Okay, after plugging it in on Desmos, it's actually set of all real numbers, but it cannot touch this vertical asymptotes. So at x equals 2 and x equals negative 5, your graph are not touching those restrictions. So those are your answers. X equals 2 and x equals negative 5 cannot be your domain. So the answer is B. Number 3, what are the domain and range of the function y equals all these? Let's go ahead and plug that in on Desmos. Okay, so this is your graph, and as you can see, your domain is from left to right, except that your graph is not touching this asymptote, this vertical asymptote of x equals 4. And so your domain is a set of all real numbers except for 4. It will not touch 4. Okay? And your range is actually from bottom to top, except that it's not touching this horizontal asymptote, which is y equals 5. So your answer is A. We're now on objective 2. I can graph rational functions. Which of the following is represented by this graph? In this particular objective, all you need to do is use Desmos and match the graph to the right equation. So let us begin. This is letter A and the graph doesn't match. Let's plug in B. And this is letter B, and again, the graph doesn't match. And now for letter C, it matches. So the answer here is letter C. Just to emphasize, guys, this broken lines right here are just the horizontal and vertical asymptotes, which are just given for emphasis. But right here, it will not be given because we did not graph them. So again, the answer is C. Objective number 3, I can analyze the key attributes of rational functions. I can analyze the effects on the key attributes of the rational parent function when f of x is replaced by all these transformations. So let's begin. Number 1, let f of x is equal to 1 over x and g of x equals 1 over x plus 7. What is the transformation? You can plug this in on Desmos if you like, but I hope that by now you already know that if you are adding or subtracting a number to your function, that it is a slide or it is a translation. So it's all translation. And if the addition or subtraction is happening outside the parentheses or without the x, but you're adding it to the whole f of x, you know that this is a movement of up and down. So this is translation 7 units up. Question number 2. Identify the x-intercept of the function. This can better be done using Desmos. So let's plug it in on Desmos. Alright, so after plugging it in, this is what we got. We just have to look for the x-intercept, which actually, using Desmos, it will right away give it to you. So the answer here is negative 2. Let us go to number 3. Identify the vertical asymptote of the function. Plug it in on Desmos. After plugging it in on Desmos, we can actually see two vertical asymptotes. One is right here on positive 3. This is your vertical asymptote. And the other is x equals 0, this right here. So those are your two vertical asymptotes, x equals 0 and x equals 3. And so the answer for number 3 is B. Number 4, what are the vertical and horizontal asymptotes of the function? Let's go ahead and use Desmos. All right, so this is what we have after plugging it in on Desmos. And I can see right here that your vertical asymptote is at x equals 2. So that is your vertical asymptote. And your horizontal asymptote is here with y equals 3. So your answer right here is letter A. Now let us do number 5. Which function shown below shares a 0 with the rational function? This one. Let's go ahead and plug this in first on Desmos. Let's see what the 0 of the function is for this one. And then we will plug this in one by one to see which one shares the same 0 of the function as this one. All right. Let's take a look at this. And the 0 of your function here is 3. Once again, let us remind ourselves 0 of a function has another name, which is x-intercept, also called the solution. Okay, so let's go ahead and plug in your answer choices and see which one also crosses this x-intercept. All right, so after plugging in letter A, I think we have spotted the answer because these two are sharing the same 0. This other point, guys, is not on the x-intercept. It may look like it because we're too far, but if you zoom in, you would see a gap, and that is not an x-intercept. This is an x-intercept, which is the 0 of your function. Therefore, the answer to this question is letter A. Okay, so let us now go to number 6. Where is the hole in the graph of the rational function? This one. So this must be done by hand. We're going to go ahead and do this manually. All right, let's go ahead and start finding the hole of this rational function. Notice that your denominator can still be factored out. So let's go ahead and find a number that if you multiply will be a negative 21, but when you add will turn to positive 4. Copy down your numerator. Make 2 sets of parentheses for your 2 binomials. Your first terms will be x and x because this is x squared. And then think about the possible factors of negative 21 that when added will give you a positive 4. In this case, I know that negative 21 is positive 7 times negative 3. And I know that when I add them, it will give me a positive 4. So these are your second terms right here. After doing this, you're going to simplify your equation by canceling out x plus 7 on both the numerator and the denominator. Okay, after simplifying and canceling these two out, we're going to now begin the process of looking for the coordinates of the hole. And so this is where we're going to start. This 2 right here that you have removed, you'll have to write that down. And you will set it equal to 0. And now we have found the x coordinate of your hole, which is x equals negative 7. Let us now go ahead and find the y coordinate of your hole. And this we can do by plugging this in into the x of this simplified form of your fraction. Okay, you're going to substitute your x, which is negative 7, into the x right here. So now you will have y equals 1 over negative 7 minus 3. And then you will solve for it. So now y is equal to negative 1 over 10. So now your hole is at negative 7, comma, negative 1 out of 10. I hope that you have learned a lot today, and good luck in taking your power focus assessment on rational functions.